Okay, so now we have all the geometry set up. In the latest video, you would have seen that we set up this nice little frame for the part. And in this video, we're going to go ahead and start getting the machining done. So first of all, one thing that I want to make sure is in my main link body, I'm going to include this frame also in there. So in here, I'm going to have the two items, which is the part and the frame. The reason I'm doing that is when I come to rough this part out, I don't want to include the frame as check. I want it to think that this part, the frame is also the part. So when it's roughing, if I determine half a mil, it's going to be half a mil off here and half a mil off here. Okay, so this will be in my roughing, and in my surfacing, I haven't got any frame in there so far. So let's start roughing this out, I think. So let's just double check our stock bullet. So I think the first toolpath we'll do is let's start chomping out the middle of here, all of this stock inside these pockets that you can see. I think it's time that we start getting rid of that in there. So I'm going to go ahead and get a tool selected. So now this is starting to get a bit repetitive now, so we're going to start upping the ante a little bit and getting a bit faster with our toolbox dialogues and stuff like that. First of all, you can see we've got a generic machine selected in here. This might be the same on yours, it might not, but don't worry about this carrier. That's it's something related to the post, so just for this tutorial, we're just going to dump everything under generic machine. So I'm going to insert tool, mill planar. We want just a normal mill, and I'm going to call this 6 mil end mill. Radius 1. Yeah, and normally I would just put like whether it's a roughing end mill, because depending on the type, most tools, you know, you're going to get provided with roughing end mills and finishing end mills, and ideally if you're using them for roughing, you don't want to use them for finishing. So this is why I would normally put the roughing, or I wouldn't necessarily put finishing, but if it is roughing, I would definitely state it. And we'll do a half mil radius. Okay, so diameter is 6. Lower radius is half a mil. The length would probably normally be about 15 mil. Length will be about, let's say 40 mil, and the flute length will be about 15. The relief diameter, that doesn't matter. And we'll call this tool 1. Okay. Now we can go ahead and start our program. So the top level, I always like to call the name of the part. So part 3 dash op 10. So that's our top level, and then inside there, I'm just going to copy and paste this one. Dump it inside, and now this is where I'm going to start making things nice and neat. So first of all, we're going to rough. So rough in 0.5. I'm going to rough to half a mil. Okay. Now in here, I'm going to go ahead and insert our first operation. So the first operation for me on this, I'm thinking it's going to be a 3D adaptive rough. So let's go ahead and select that. So the reason why I'm selecting that is we could cavity mill these out and just go level by level, but I think going all the way down to the floor and then coming out as much as possible, I think that's going to be the better approach. Just because it sort of sits itself nicely for an adaptive pattern, using as much as the flute as we possibly can. And yeah, to me, it's going to be the better way. So we want it to live inside the roughing group. The tool is going to be this one, and our geometry group is going to be the main link body. And so we haven't set up our roughing groups yet, so let's go ahead and just do that. So mill rough, I'm going to go to half a mil there. Semi-finish we're going to need, and I'm going to do that at 0.1. And I'll finish, that's fine. Okay, back into here then. Now we can put this under a group. That'll be intolerance and clearance method group here. So we want that to be under the rough group. Okay, so now we can start working through. So the range type we don't want on automatic because we want to specify the floor that we want to go to. So for the top level, you can see it's actually automatically got that for us, which is nice. And then the floor is going to be, we've got 15mm of flute length, so we want to go 14mm deep, and the top face is seen as 1.5. So if we go minus 12.5, that should give us 14mm depth, like so. That looks like it's going to be deep enough. Like I say, we don't have to rough all the way through this. We just have to rough like a good portion past halfway for our surfacing toolpaths. Okay, depth of cut, 95% of flute, or you can just, yeah, that would be fine. But in this case, I'm just going to define it as 14mm. So top off flats. So I actually don't want to top off flats because it's going to be a waste of time cutting, really. I'll show you it. We'll generate it with and without it. So let's do without it first. Bottom up cutting. We can play with that. That could be quite useful in this case. And minimum curvature radius. Let's just up this a little bit to 15% to stop it wrapping in those corners like we described in a previous lesson. Okay, this all looks pretty good. Check we don't need to add because this frame is included in the part in the geometry group. Don't need any trim boundaries, so in process workpiece always want this on. And 0 for the first one will cut as much as it possibly can. Tool axis Z, feeds and speeds, so depending on the tool, depending on the material, we're going to say this is aluminium, so we're going to say something like 13, maybe 14,000 with a 4mm tool, and around 3,600 feed. Well, let's just double check what my step over was there actually. Where's my step over here? 8% of the tool. That's a bit small. Let's go 15%. So feeds and speeds are set. Strategy, adaptive pattern, that's fine. So adaptive pattern will helical down. We actually want helical motion here because it's in an enclosed pocket. It would do this anyway by default because it sees it as closed. So, but now you should see some helical move down to the bottom in here and then sort of coming out. Non-cut moves, so that all looks good. We're going to helical engage. You can see on the picture. Ramp angle we can increase a little bit with this being such a soft material. Let's say 4. And then the height, we want to go from just 1mm high. 1mm above the job should be fine. Okay, retract, that's fine, that's fine. Traversal, safe part clearance, that looks fine. That looks fine as well. And then clearances, let's say 1mm and just 0 there should be fine. Because it shouldn't actually ever be getting that deep to get in the way for the neck. For the shank, sorry. Because we're only going 40mm deep, we've got 50mm of flute, so should be fine. So let's generate that and see what we get. So that is pretty much exactly what I was expecting. Looks quite nice. Let's just play that on the. So previously I showed you how to use the verify toolpath, and you could watch it like so. 3D dynamic, and then we could sort of watch it through like this. The other way to do it would be to, you can just use this tool up here, the toolpath animation, and if we just turn on the display IPW, then we can watch it through here. So, same thing. Probably a bit faster doing it from up here, it's just a bit neater, isn't it? Okay, so those 4 pockets are roughed out. So now we can start looking at this toolpath and sort of think, is it doing the most it possibly can? So the next part to look at would be what do we gain for doing bottom-up cutting? So we're going to get a bit more definition. You can see by roughing out these pockets, we're not really defined the part very well. And also, I would like to see if I can force it to come down here. So in my head, straight away, the reason why I think it couldn't get in here is because of this engage here, the diameter at 90%. If we put this down to say 50 to make the engage a bit smaller, we might get something. We might get something coming down here now. Yes, there we go. So now it's coming down and it's roughing down this crevice as well, which is nice. So this is where I'd start to think, you know, how we want to keep this diameter as big as possible, really. So I'm going to start playing with it and seeing what we can get away with now. So 60% it works, and we know 90% didn't, so we'll try 70. 70 looks like it still works too, so it looks pretty close, as close as we could probably get it, so I'm going to leave that there. So now we've roughed out the outsides, we've roughed out the insides, but we've got no definition. So let's just have a quick look what that looks like. Okay, so not too bad. So now I'm going to add bottom-up cutting. Let's add that on. And we'll say after the last level. And let's do, let's just do 2 mil step-ups for now. And what you'll get is 2 mil levels of working up, basically. So let's check that out. So now you can see it's actually seen the outside of the part as well, because it's not just gone straight to the floor, which is probably lower than this level here. So this isn't ideal, so I don't really like how it's done this here, but we can definitely change that. Let's just see what we get with the toolpath first. So we get a couple of levels coming up, but not a massive amount. It will be slightly better. So let's try, and let's also, it's good to bear in mind the time as well. So if we just have a look at what time it says. So 6 minutes, 22 seconds. So if we generate it without bottom-up cutting, because we just want to see how much extra it's going to take, basically. So let's turn that off. So the bottom-up cutting added 2 minutes. So if we do 1 mil, because we're going to have to rough that anyway, you'd have to come in with a different tool or the same tool and do like a cavity mill. So let's see if we can do bottom-up cutting on after last level, and let's say 1 mil step-ups to see if it can get the top of this face here. And then the next thing I'm going to do is I'm going to restrict it by using a trim boundary so it doesn't see the outside of the part. So I'm going to say trim boundaries, curve, I'm going to select this top curve, and I'm going to trim everything outside. So I don't want to look at anything outside of this circle, basically. Okay, this looks like it's a bit more defined now. It's doing a bit more, you know, a bit more of what we don't necessarily want, a bit more wasted cutting, but let's just see. Let's see what we've got. So here straight away you can see it's tried to get the holes, so we can restrict that again. Because ideally I'm just going to use a helical milling operation to get down them. I think that'd be a bit faster than doing these little tiny cuts here. this is more like it. This is more like what I wanted. So this is exactly what I wanted now, other than these little cuts that it's doing inside of the holes. So another way that we can restrict it going down those holes is we should be able to use avoid small area. So here we can stop it going into the hole. Currently it's set to percentage tool diameter, which if we increase a bit, I think that hole is like 10 mil. So I wonder if I tell it not to do that, if I put 10 mil in there, I'm hoping it still gets down this side wall. No, so now it's not getting the side wall, which isn't ideal. So the next way we can restrict it is by putting that back to 70. What's the best way to do this? Put this back to 70, which will give us the same toolpath as we had before. And maybe we blank off these holes in this geometry, which would stop it diving down there. This is almost exactly what I want. It's just this is what I'm trying to restrict now, these holes here. So go back to our geometry group here, main link body. So now what I'm going to do is I'm going to create a new group, and this one is going to be called roughing body. And this roughing body is going to be this exact same body that we can see here. The only difference is going to be I'm going to add some caps over the top. So if we go to geometry now and you see these patch openings, we're going to patch these holes up so that we get a surface on top of them basically. So the easiest way is just to select the top faces like that, and then the edge to patch is this one. And that should give us patches like so. And I'm just going to put these into a feature group. So I need to be a model in for feature groups, remember. I'm going to put these into a feature group called roughing body, like that. So now what I'm going to do, I'm going to switch back to manufacturing. And now I can include these surfaces in this roughing body. So you can either just go and select them. So to select them, because they're sheets, you have to switch the sheet body in the menu up here. Like that. Okay, so now if I hit this, you can see all of this is one body. And I'll just drag this 3D adaptive roughing under the roughing body and regenerate it. Perfect. So let's just look at how that looks now. That's great. Yep, that's exactly what I wanted here with this toolpath. Okay, nice. So now I can turn these off, and we've roughed out this part basically complete as much as we can. The next thing we need to look into is I also just want to rough these holes out, and that's just purely just to get as much weight as I can out of these holes. It probably wouldn't make too much of a difference for a part like this, so shall I just leave it till the end? Because what do I need to do next? I need to surface the part I think we put these countersinks in at least. I think we roughed the countersinks out. So let's go ahead and we need to create our geometry group for the holes. So that's going to live under the main link body because it can't live under the roughing body because now we've got caps over them in the roughing body. So obviously you can see here, so we can't have holes in there. But in this one, we can have holes. So I'm going to insert geometry, feature-based machining, sorry, hole making. I want this hole boss geometry, and I'm going to call this, what size are these holes? 6mm, I think. Yep. 6mm H7. So I'm going to call these 6mm H7 holes. And in there, I'm going to have all of the selected holes. Like that. Now I have my nice hole group, and let's just rough them down now. Insert operation, hole making, hole milling. I think we've used this one before. Same tool, same group, main link body. Now the geometry is going to be our hole geometry, and the method is going to be rough. Now in the specify feature, we need to make sure we've got the top cylinder selected. So we don't want the second cylinder, we want the top one selected. So we can see here the diameter of that is 9.5mm. So I think it's actually 10.5, but with 0.5mm stock on each face, it's telling us that the diameter should be 9.5 with the stock on here. Okay, and one other thing that we want to do is we just want to leave some stock on the floor. So when it comes in as standard, it doesn't leave any floor stock on. So although we're leaving 0.5mm on the walls, it wouldn't on the floor, it would go straight to depth. So let's just make sure we add that 0.5mm on there as well. Okay, geometry's fine. We don't want any cut or comp for this. Speeds and feeds, let's keep it the same as what we had before, 14,000. And our feed is going to be a lot slower now because we're inside of a hole. So you can imagine when you've got all this space to work around that, you can get up to maximum feed rates. But when you're in here, you don't want to be too shaky. So I would always say on alley, more depth per cut and less on the feed for holes. Maybe like 300 should be fine. And then the depth per cut, we don't want to be too fast on the depth per cut. We just want to go a little bit less. So nothing crazy. On the pitch we'll go 0.3, something like that. That should be okay. Step over, should be fine. Like we don't need to worry about that. Actual step over, we need to put to passes on 1. So we want to do it in 1 pass as it's coming down. We don't want to like helical down to a mil and then up and then helical down another mil and back up. The radial step over, that can be left at 50% because it shouldn't be more than twice the diameter. So for example, if this was a 20mm hole, then you would start adjusting this, but as we're going to do it in 1 pass anyway, it should be fine. Top offset. So if we do 2mm, because we have left a little bit of stock on the top face. And then bottom stock, that's irrelevant because we're not on a through hole. Let's generate that and see what we get. Okay, that looks good. So this traversal height's a bit high, so that's a bit overkill, so we bring that down a bit. Automatic and free, it should be fine. Yeah, that should be fine. That looks good to me. So let's just play that through. Turning on the IPW. So you can see we are starting above the stock level here, which is ideal. Okay, so to me this part I would say is completely roughed from this side. We've done as much as we needed to. It might be worth breaking this through. Thinking about it now, it might be worth breaking this through because if we break through all the way around here and on the insides. It might allow the part to bend and flex a little bit if it's going to. I doubt it will that much, but if you're going to get any movement, it's probably best that we break that through now and then held on the tabs. It might allow it to just distort a little bit because we want the distortion to happen now on the roofing before we go to the finishing. So let me let's change that. We are going to do that. So on the depth, I want to go all the way through the part. So I'm just going to select the floor and then just make sure I go a little bit past. So 21mm deep. And I want to do that in 2 cut levels. So that'll just half it. Okay, so we should be able to see the toolpath underneath it now. Yeah. So if we play that through, we can just make sure. Yep, so that first pass is not. Yeah. It's doing the first level, then it's going to do in the second level, and then it does the bottom up cutting. Yeah, that looks good. Let's speed that through. Actually, let's just speed the whole thing through quickly. And then this will bring us to the end of this lesson after we've roughed this part out. And then we'll get on to the surfacing in the next one. So you can see even just on the roughing, it does take a little bit of time, a little bit of thinking. I could have quite easily have just roughed that out in one toolpath and then come in with another toolpath to create a bit of definition and another toolpath to do other things. And I don't know, but I like to just get one toolpath down and sort of think, is this the most this toolpath can do? How can I get more definition? And you've sort of seen me work this toolpath up here, which is good. So now you can see this is actually really nice. This is exactly what I want here. Yeah, I'm happy with that. That's good roughing. Okay, so that is this roughing finished, and we'll get into the surfacing on the next video. Okay, thank you.